Good afternoon, everyone. Welcome and thank you for joining our webinar today. My name is Ashton Pratt, and I'm the Commercial Operations Manager for Stair, and I'll be our moderator for today's session. Quick note prior to starting, we'll have a moderated Q&A available throughout the presentation, so please post any questions to the Q&A as they come up, and we'll answer questions through the Q&A comments as we go. And then we'll also have a separate Q&A period at the end of the presentation. We'll do our best to answer all your questions, and for any that we either cannot get to or that might require some additional research, we'll send responses to those in a follow-up email to everyone who attended. Our presentation today is titled Designing Crossover Stair Systems for Space-Constrained and Congested Workspaces, and it'll be presented by Matt Proctor. Matt is a Senior Account Manager for Stair. Matt has extensive experience designing crossover stairs and other access systems for many applications and industries. And he works closely with designers and engineers to create safe, code-compliant stair and platform designs that optimize the efficient use of space. And with that, I will turn it over to Matt.
Great. Thanks, Ashton. In addition to Ashton's duties as operations manager, Ashton is also a prolific contributor to our website, our resource page on our website. He has written several white papers on code-compliant stairs, stair design, safety and ergonomics. He's developed an OSHA working and walking surface fact sheet and checklist list. And if you have a stair question or anything stair related, there's a good chance that Ashton has written about it, and it can be found on our resource page on our website. I want to thank you for joining us for our presentation on designing crossover systems for space-constrained and congested workspaces. On today's agenda, we are going to talk about the value of crossover stairs, space-saving stairs versus standard stairs, comparing different types of space-saving stairs, key design considerations when designing crossover stairs, options for configuring crossover stairs, and we're going to conclude with some case studies and examples of crossover systems that we've developed. Value of crossover stairs. We came up with 4 compelling reasons to include crossover stairs in your conveyor system layouts. They are safety, efficiency, egress, and access. These images are clearly AI generated. They do show real-life scenarios of what workers will do when they're not given clear and efficient access and clear travel routes. When I was in prep school, we had our dormitories across from some athletic fields, and we had across the athletic fields were the academic buildings, and we weren't allowed to walk across the athletic fields because of foot traffic. They didn't want footpaths being worn in the athletic fields, and so we had to go around. Well, if you were running late for class, and you didn't think anybody was looking, you would, run across the athletic field and hopefully try not to get caught. And I think, a lot of times workers in warehouse situations will have the same mindset. Do they really want to walk around 100 feet of conveyor to get to a break room or to go speak to a manager or supervisor? A lot of times they will crawl underneath a conveyor or hop over a conveyor. A couple months ago, we had an account manager who went into a distribution center to visit with a customer who asked him to come in, and they had that exact situation. And he said they had well over 100 feet of conveyor that the workers would have to walk around in order to access a break room. And he said even the people who were with him were crawling under the conveyors or sliding underneath the conveyors just so they wouldn't have to walk around. And so By adding crossovers at strategic locations, you can minimize that, create safer, more efficient travel routes for your employees and your and the owner's employees. In addition to safer travel routes, crossovers there provide access to hard to reach areas and safe movement over tripping hazards. This picture on the left is a multi-stair crossover accessing an ASRS cube system. In addition to accessing the cube system, it also is providing access between the conveyors. The picture on the right is a K-cup packaging facility. And this is an L-shaped crossover going over conveyors that are somewhat low to the ground that you could easily step over. But if you can see in the picture, there's conduit, there's airlines, there's some electrical fittings, all which would pose a tripping hazard if you were trying to step over the conveyor system. And so this customer asked us to develop a system. This is an L-shaped system, gives them access up and over the conveyor line. Crossovers and bridges and stairs can also be used as part of an exit route. OSHA calls for exit routes to be free and clear and unobstructed. Stairs and ramps must be provided where an exit route is not substantially level. Space-saving crossover stairs versus standard crossover stairs. What are the differences and how much space can you expect to save with a space-saving crossover stair? We'll start by describing what is a standard stair. Standard stairs are classified by OSHA and IBC. The stair on the left is a typical OSHA stair, and the stair on the right is a typical IBC stair. There's some subtle differences between the two. OSHA can be a steeper stair than a traditional IBC stair. It's going to have a max riser height of 9.5 inches, a minimum tread depth, of 9.5 inches, and a stair incline between 30 and 50 degrees, closer to maybe 45 degrees, a minimum width of 22 inches, where an IBC will have a minimum width of either 36 or 44 or even greater. Both will have 42-inch guardrail. The OSHA stair will have at least one separate handrail, and depending on the width, they'll have an additional handrail. IBC will always have two handrails on both sides. And the guardrail opening, the OSHA stair is going to have a 19-inch maximum guardrail opening. And some stair manufacturers achieve that through horizontal rails. We achieve that through vertical balusters. Both are code compliant. IBC is going to have either two criteria for openings. If it's an IBC commercial application, it's going to have a 4-inch maximum opening. And if it's IBC, what we consider industrial, they allow up to 21-inch max opening. I get this question sometimes, what is IBC industrial? Is it a separate spec? And it's not. It's part of the IBC specifications. It's just the occupancy classification for where you can use the industrial stair opening. And those are going to be in classifications I for institutional, I3, F for factory, H for hazard, high hazard, or type S for storage. Those will all allow stairs with an opening up to 21 inches. So those are your standard stairs. Now we'll talk about space-saving stairs. OSHA and IBC describe 4 different types of steep incline stairs. We have pictures here to identify 3 of them. The 4th one being a spiral stair. We really don't see a use case for spiral stairs in industrial applications. So we're going to focus on the three that OSHA and IBC recognize. In the upper left corner is the alternating tread stair. The top right is a ship stair, and the bottom is a fixed ladder type crossover stair. Stairs can be grouped into their incline, with standard IBC stairs being 30 to 32.5 degrees, OSHA stairs being between 30 and 50 degrees, where ship stairs and alternating tread stairs can be between 50 and 70 degrees. Our alternating tread stairs we manufacture to 56 and a steeper 68-degree stair, while ladders can fall into 60 to 90 degrees. Please excuse me for a second. I'm having an issue with the slide. Okay. How much space can you expect to save using a space-saving stair or steep incline stair? With our alternating tread stair, we can see savings of close to 50% over a traditional stair. And if you look at the chart on the left, we have 4 different obstacles, hypothetical obstacles that you would need to clear. At 48 inches by 24 inches, a standard stair would have a horizontal footprint of approximately 126 inches. Using the 68-degree alternating tread stair, you would save 51 inches in horizontal projection or horizontal footprint. That represents a 40% savings over a standard stair. And as your obstacle becomes higher, your savings of floor space becomes greater. So if you look at the last line of our chart, if you have an obstacle that's 78 inches tall and 24 inches wide, using a standard stair would be 194 inches. Using a crossover with a 68-degree alternating tread stair would have a horizontal space of 99 inches with a savings of 95 inches. And that's a 49% savings over a conventional stair. Design considerations for when you can use a standard stair versus a space-saving stair, and what type of design constraints that you need to know when specifying or designing a stair. For crossovers, one of the most important dimensions that we need are called clear dimensions. And I define clear dimensions as vertical and horizontal dimensions that are required to cross over your obstacle inclusive of all your clearances. And so when you specify a clear dimension for a crossover stair, we're going to assume that you have already put in all your clearances and buffers that you are anticipating. And what this does is it prevents what we call clearance creep, where extra clearance is added at different points in the process. And so maybe a designer is going to add in maybe 3 inches or 6 inches of clearance. And then maybe the project manager adds in, another 6 inches, and it can creep and it can become a much larger stair than it needs to be. And larger stairs obviously cost more. And so by specifying a clear dimension early on in your project, it can prevent clearance creep where you're ordering a stair much larger than needed. Some clearance considerations when you are designing a crossover stair is the height of the conveyor plus allowable variations for adjustment. So if you have a floor that isn't level and you have to adjust the height of one end of the conveyor, that needs to be accounted for. Height of transported items and variations of those items. Do you have a cardboard box? Is there a potential for a cardboard box lid to be open? Things like that. Obviously, you're going to add a clearance buffer for variations. And then is there any future considerations of items being transported on your conveyor line that you may want to account for? Horizontal clearances, the width of the conveyor itself and the width of the transported items, the added width of conduit lines. One commonly overlooked item are safety switch cable poles that run on the sides of the conveyor. They can stick out several inches. Electrical boxes, and any clearance buffers that you feel necessary. In addition to those considerations, there's head height clearance. OSHA requires a minimum head height of 80 inches. So in the picture to the right, standing on top of the platform, he needs to have 80 inches of headspace from the top of the platform. From the top of the platform to any obstacle, you need to maintain 80 inches of clear headspace. In addition to headspace, OSHA requires 30 degrees of clear travel in the direction of travel. And so as you ascend a stair, your platform needs to be 30 inches minimum. And at the bottom of the stair, you need 30 inches free and clear from any obstacle. So some obstacles that you may run into when designing a crossover stair are fork truck aisles and exit route aisles, doors in mezzanines, door swings. Can the door swing open? Can you maintain 30 inches free and clear with the door open? And then if you incorporate a stair into a piece of machinery, do you have 30 inches clear around the machinery? An additional consideration is the floor. Is the floor level or is it sloped? When measuring for a stair, you want to consider where the stair sits and a vertical plane to where the stair is going to land. Also, the example on the right is a roof parapet, and the roof heights are different. So one side of the crossover has a different height than the other side. When considering using a space-saving stair versus a standard OSHA or IBC stair, there are some code considerations. OSHA would like to see standard stairs used when operations necessitate regular and routine travel between levels, including access to operating platforms for equipment. They allow for space-saving stairs when the employer can demonstrate it's not feasible to provide standard stairs. Another consideration when using space-saving stairs is, do objects need to be carried up and down the stair? OSHA stipulates that no employee can carry an object or load that would cause employee to lose balance or fall when climbing up and down a ladder. Ladders also will require 3 points of contact at all times. If you anticipate your workers carrying small tools or parts or small boxes, that should be a consideration in the type of stair that you specify. Comparing different space-saving stairs. In this graph, we compare an alternating tread stair to a ship's ladder or a ship stair. The alternating tread stair is going to have a full tread depth of 8.5 inches minimum, where a ship stair is going to have a tread depth typically of about 4 inches. The alternating tread stair is going to provide 4.5 inches more tread depth, creating more stability. The alternating tread stair is also a face-forward design. And so you face forward while you're ascending, and then while you're descending, you are facing forward as well. And in that way, you can see fork truck traffic, any oncoming obstacles. And it's also a more natural way to ascend and descend the stair. Virginia Tech did a study comparing the alternating tread stair to ship stairs and ship ladders. 72% preferred the alternating tread stair for safer ascent. 89 preferred it for a more comfortable ascent. 82% of participants preferred it for a safer descent, and 85 preferred it for a more comfortable descent. And that was a study done by Virginia Tech. Alternating tread stairs versus ladders. As I mentioned, the alternating tread stair has a face-forward descent. The user's center of gravity for the alternating tread stair is directly over their feet, improving stability. With the alternating tread stair, you have a free hand, as I mentioned, to carry tool bags and small items. It allows for a more neutral body position. Users can see obstacles and objects in front of them. And for me, the most compelling reason to choose an alternating tread stair over a fixed ladder is the reduced stress on hands and wrists, much less risk of repetitive use injury. With the alternating tread stair, a majority of your weight is being transferred to your feet in a neutral body position, where with a fixed ladder, your hands and wrists are taking a much greater portion of that load. Stair and ladder safety in the workplace. This is from the Bureau of Labor Statistics. Ladders account for 22,594 yearly injuries, where stairways are about half that. 149 average fatalities per year with ladders, 25 with stairways. An estimated 1.1 billion in workman comp claims as a result of ladder use versus 490 million compared to stairs. Options, excuse me, options for configuring crossovers. We can kind of segregate these into two different categories. All of our crossovers are made to order. But we have what we call standard crossover options. And those would be your 90-degree turn, your 90-degree left turn, and we call a U-shaped 180-degree crossover. We're certainly not limited to those, but those are just easy to define. They're easy to specify, really. You can click on, you can check off a 90-degree crossover, give us the clear dimensions, tell us what type of stair, and we can generate a quote from that. The row on the bottom are the different types of stairs that the crossovers can be configured with. And it's not limited. We can do hybrid crossovers, and I'll show you later in the presentation a few stairs where we've done that, where you could have an alternating tread stair, maybe drop between some conveyor lines, and you could have OSHA stairs on the ends. So we're not limited, but these are kind of more of your standard options. And then we go into custom crossovers. And for the remainder of this presentation, we'll go over some of the custom crossover configurations that we've done in the past. And this should give you an idea of our crossover capabilities. So this is a custom crossover that we developed for a customer that was that needed to cross over a multi-line conveyor system. Here we have the alternating tread stair dropping between the conveyor lines. This is a hybrid conveyor crossover system. This is going over 2 conveyor lines and then providing access. This was in that picture of the ASRS cube system. This is a Z-shaped OSHA crossover system. This is a fairly complex series of work platforms and stairs. This is for a distribution center that uses a pallet system. But this isn't a crossover, but I decided to include it in the presentation because it's a good example of space-saving mezzanine access. In a lot of warehouses, we see mezzanines or second-story office space. This is an alternating tread stair with an intermediate platform going up to a mezzanine and exiting left. And then we have some case studies and real life examples, pictures of some of the systems. And these correspond to the drawings that I just showed you. This is equipment mezzanine access. And this is the middle picture is a situation where you wouldn't want to stair, a traditional stair, impeding access to that door. That aisleway is free and clear because of the space-saving stair. You would not be able to use a standard OSHA stair or an IBC stair in that application. And the drawing to the right, this is a similar situation where we're using a switchback alternating tread stair system to access the mezzanine. There are several food and beverage applications. This is crossing over a K-cup filling conveyor line. And the middle one, this is beverage, and the right is an OSHA crossover over a beverage line as well. This is a multi-line sortation system. This is the ASRS pick station I showed before. Here is a series of IBC compliant crossover stairs. And this is the last slide. It's not, I included it just to give you a broader sense of some of the applications, outside of warehouse and distribution and conveyors systems. We sell a lot for roof access, piping crossover systems, rooftop access systems, parapet systems as well. And that concludes our presentation. We'll open this up to Q&A. My contact information is there. If you have any questions, you want to email me, or if you have an application you'd like us to look at, my contact information is in the lower left corner. And thank you for joining us.
All right, thank you, Matt. Great presentation. As I mentioned, we reserve some time here at the end for questions. So if you have, we have one question here. But if you have any other questions, please post them to the Q&A comments. I see a question is 12 foot the number for alternating treads for a landing, and the alternating tread can extend up to 20 foot in a single run. We recommend a landing at around 15 feet. Taller than that, it can pose challenges for people who may feel uncomfortable going taller than that in a single run. So do recommend around 15 feet to have a landing if you have space. But if not, the alternating tread can go up to 20 feet tall. And I see someone else posted that same question. Okay, well, if there's no other questions, we will end the presentation. Again, thanks. Thank you, everyone. Okay, so let's see, there are more questions coming in. A question about can the alternating tread be used as primary means of, I guess, egress under the IBC? I think the answer is that the alternating tread can be used in special cases as primary egress for small mezzanines under 250 feet, square feet, and less than 5 occupants. So that would be, for small storage areas, also for control rooms and other guard stations. Let's see, another question. Is the standard stair less expensive than the alternating tread? Generally, the alternating tread is less expensive than the standard stair, just as a sort of a function of less material, steeper angle. So over the same height, usually the alternating tread is a little less expensive than a full-size stair. Matt, maybe I'll give you what is a common oversight you see from clients when specifying crossover stairs, and what steps do you suggest to avoid this in order to minimize additional costs?
Sure. The OSHA 30-inch rule, we see that quite a bit. Not maintaining 30 inches free and clear at the top of the stair and crossover, as well as the bottom of the stair.
Yeah, and as far as minimizing costs, it's really, the main cost drivers for stairs are usually the width of the stair or the width of the platform and the height. So, like Matt said, the height creep. If you specify a crossover that's just too tall, it'll become more expensive. And then also the length of the platform at certain size, like our platform systems go about to 12 feet long. After which point you need additional support structure to keep them to meet the engineering requirements. So that would drive costs, and then the width. So our the sort of the minimum width of a crossover is about 24 inches, and if you specify one that's 36 inches wide or 48 inches wide, without necessarily needing that, that would drive the cost up unnecessarily.
Tread and landing material can also increase costs. Bar grading being one of the more expensive options. Diamond plate being the least expensive.
And then one more question: Do you have a setup? Do you have a setup of IBC OSHA requirements that are available to us? We will provide this presentation to everyone following the in a follow-up email. And we can also provide, we do have a pretty thorough checklist or document for all the IBC and OSHA requirements for stairs and landings, and we can include that in the follow-up email. Okay, I think that's all the questions we have. Again, thanks everyone. We appreciate it, and we will follow up and be in touch. Thanks.
Thanks, everyone.
Bye.